Okay, dann machen wir weiter. Wir bleiben beim Thema Robotik mit der Firma SCHUNK. Und zwar genau genommen mit Martin May von der Firma SCHUNK. Und ja, wer wird darüber sprechen, what it means to build smart grasping services. Und während wir hier
Alles klar.
Voraussetzungen schaffen, dass er loslegen kann, noch kurz Hinweis auf die Podiumsdiskussion nachher um 13:30 Uhr, Women in AI, und davor dann der Vortrag vom Professor Sami Haddadin. Also es bleibt spannend und genau auf dem Level, auf dem Spannungslevel machen wir jetzt weiter.
Okay.
Jetzt habe ich die Latte besonders hochgelegt.
Yeah,
Aber ich bin mir sicher, Sie schaffen das. Also Herr May, Sie dürfen loslegen, bitteschön.
I'll do my very best. Ich habe jetzt gesagt, ich mache ihn auf Englisch, von daher Fragen gerne auf Deutsch, aber wegen der Übersetzung ist es, glaube ich, einfacher. So, thanks for coming here. My name is Martin May. I'm from SCHUNK, and I'm going to talk about the story, basically how we see digital transformation and the problems we encountered by building our smart services. And I want to start with an analogy which I found indeed from it's an example from Amazon, but it fits perfectly well to what we also encounter. Is that when you come from an industry, steam engines at the time, and you wanna and you work basically on how this will evolve, what you would do is the very straightforward way. You're just gonna put more coal. You're gonna build more stronger steam engines, but that only lifts you to a certain level of excellence. The big changes always come when there's a change in the entire process, and that happens when you go from steam to electricity. That was a major change that happened, but that doesn't stop. The next evolution, I think everybody heard about Elon Musk. So Hyperloop will come, and there will be a major change because we're shifting completely technologies. Why is that so important for us? And I want to bring up another analogy about digitalization in general, looking back of how you did travel arrangements a long time ago. At the very beginning, everything was analog. You took your maps, you planned your journey, and with that, you start driving. The next level, what happened is that you started using Google Maps. Everything was digital. The information about where streets are and how occupied they are was available online. So you made the switch from regular analog maps into digital maps. What we are doing right now is we integrate autonomous devices, and that's the self-driving cars. So we want to make sure that even the cars in the future are able to drive around, take into account all the information that is around about occupation of the streets, how many traffic jams, and so on. And we want to make sure that with that, the distributed systems, which in that case are the cars, they're able to decide autonomously what to do next. And the final step, of course, is to build something we call the autonomous network of all the different cars in the way that we're going to avoid traffic jams, that we're going to steer the traffic in a way that everything works perfectly fine. So you've realized I talked about everything but automation, robotics, and so on. But this analogy for us, or for me, is very important because that is exactly what happens in the past when we looked at how we went away from the first components were built. SCHUNK is now 77 years old. That was pneumatic grippers. The first major change was when we entered in the mechatronic devices. So suddenly you've got a lot of degrees of freedom. So you can pre-position your hardware. You can do more stuff. You can add some sensors, and you can read information while you're doing the grasp and so on. So that was the first major revolution. I don't know, maybe 30 years ago when we started, or 20 years ago when you started to build mechatronic grippers. What comes now is indeed, that's the phase we're in right now, where we're going to build the real intelligent devices, because we've got now way more capabilities of figuring out what's going on in our neighborhood. So we're going to add sensors to all the devices, we're going to read that information, and we're going to use that information just at the very beginning to use that on a local sense, but in the longer run, that's exactly what we're going to come up to, is making sure that all the devices are connected, and the gripper learns from the clamping unit, and the machine, the tooling machine learns about what's going on in the loading process or in the unloading process. So we're going to have exactly, if you compare that to the images on the upper right, is that we've got the same kind of situation, going from analog to a connected world. So this is the vision of basically where SCHUNK wants to be in a couple of years. We are right now at that stage where you're going to see in the middle. So we've got those connected devices, and we start building up our intelligence into our products. So now coming back to what I said before, it really requires a major step. So when you go for the transformation, the regular way of building your whatever kind of machinery tool is just going in that horizontal line, saying that I want to make sure that I'm gonna increase the forces, I'm gonna reduce the weight, I'm gonna increase the stroke, I'm gonna make sure that I can deal with more different kind of situations. But that is just the way that gives you a slope like that. If you really want to change the business, you really have to think completely differently, in a completely different way, that you have to build up new types of, in that case, gripping systems. You have to make sure that even when they're way more complex, because now you've got a lot of more degrees of freedom, you have to make sure that you can use them just as simple as you can do with the very simple pneumatic grippers. So you have to make sure that they're very easy to use, everybody can use them. We have to stop thinking about individual components. So the major step for us is now to say that instead of saying that we're only going to build a component and a customer can use the component for a specific purpose, we try to sell applications. We try to sell a service to a customer, because the customer at the end, he's not interested in buying a gripper, a clamping unit. He wants to solve a problem, and that is exactly what comes in the next step. And ideally, and that is what I'm going to show you 2 examples of how we realize that. We want to make sure that those systems work autonomously as much as we can. So pick and place, we're gonna see it. I'm gonna talk about the 2 examples of how we try to enable this autonomous behavior. But the first step, if you go back to that slide, seeing that the first thing we have to add is flexibility. And if you go into the regular gripping business, that's one dimension. You open or close a gripper, a clamping unit is opening or closing, even an axis going in one direction or not. So if you wanna do that very differently, here's one of the examples of what we did with our early customers. Basically, instead of saying that here is my problem, here's the one item I have to place from one place to another place, they came out saying that here is the box of tools you have to make sure you are able to handle. So suddenly you're confronted with a situation where you see all the devices you're going to see up on the screen, and you have to come up with a gripper that is able to handle all of those ones. So the regular approach saying that, oh, I'm going to use the pinching process because that fits all the time, doesn't work any longer. So basically what we did, and here you see a video that's one of the prototypes we built. It's basically saying that instead of going with the classic example of a gripper, we're going to build something which is highly flexible in the way of changing its shape, adapting to the shape of the objects we have to handle, making sure that we're going to combine with pinching, with suction cups. We can do a TISO, something which is not even integrated in that one. So basically we've got a lot more flexibility and a lot more options building just the gripping system. But of course, that gripping system is a little bit more complex than a gripper that is just opening and closing. So from that perspective, also that is important for us that we as a company understand that we are not only providing hardware, we're going to provide software tools that eases these kind of interactions. And that is basically what the focus was over the last couple of years, and what we're going to show. Well, I come to that in one of the next slides. Another important step is for the people that build automation systems right now. That is the way how this is set up normally, that everything starts with a requirement document. Somebody comes up saying that, well, we need, those are my parts, that's the way how you handle it. And basically very often we start with a hardware design. So we're gonna pick all the different, the hardware we know that we need at some point. In the next step, we're gonna write the software for the PLC, able to combine all those different devices. Then we go into the commissioning stage, and at the end we go into production. From experience, and when you talk to all the people who do that all the time, there are many failures in that process. But there's a major shift going on right now that even today or very, very soon, that process will change. So instead of going into the hardware design at the very beginning, we're going to have a complete system design in one stage where we're going to combine software functions together with hardware functions. So you're going to start by saying that I want to do a pick and place. So you pick your software solution for pick and place, and then you're going to pick the appropriate hardware which is most suitable for doing that. And that combination, it appears simple, but it's a major change in how systems in the future will be built up. It also makes, for the integrators, they're more or less independent of the hardware vendor, because sometimes you're going to find a different component which is able to provide a better performance for a given problem, and that is exactly what afterwards you can bring together. And with that, in general, you're more prone to failures. You're able to cope. It's just software that needs to be corrected. It opens more flexibility, because you can very easily change this, the strokes, the sizes, and so on. And with that, basically, I mean, we call that software-defined devices. That combination of the software with the device, here is where we see as the future, also for a component provider like SCHUNK is. So what we did, and that's basically what we're going to see here, is we came up with the first service where indeed we replaced the term of we don't sell a gripper, but we sell a gripping service we call smart grasping, with the idea saying that it's that one device or it's that one software basically. That's why it is not illustrated with a gripper, it is illustrated with a box where basically the software runs on. The goal is not that we are selling boxes, but we are selling the software that is able to handle all the different kind of objects we need to handle. With the clear goal that we want to make sure that it's very easy to use. It works basically with every industrial camera that is out there. It is open for any robot, so basically you can just plug into any robot. And of course it works with all the SCHUNK devices. And the specific idea we had at the beginning is saying that we want to make sure that after 10 minutes, all our software at the end will be workable. Just a couple of few videos and examples of how that works. I don't want to go into all the details. You're more than welcome joining me at our booth, so I can explain in more detail how we do that. But the approach is very simple. So we start by taking a few pictures of the objects that need to be handled. We do locally, so we've got the ability in the device you've seen in the box where we have a rather powerful CPU. We do all the calculations. We build a deep neural network that is able to identify the objects in the process, and with that, very quickly we can train and learn a couple of new objects in the system. The next step is you need the calibration, you need the plugin. Basically, you connect the camera, you connect all the different, you connect to the robot. You basically identify IP addresses and so on. And once this is done, the whole system is supposed to work. I skipped that one very simple part, which takes a couple of hours still, is when you train a new network. Because of course we've got a pre-trained network, but when you add some new objects, you have to retrain your network. That takes up to 3 to 5 hours. It depends on of how many images you want to integrate. But once this is done, the entire system can very easily be set up and it's working. And afterwards, what we have shown in a couple of demonstrations, of course, we can implement that pick and place. You've seen a lot of pick and place applications out there, so I'm not saying that we do something completely different, but for a company like SCHUNK, that really is a major step, saying that we go away from selling a component, but we are selling it now in terms of a service. And by the way, we talked about, we had in the speaker ahead of just before me, he was talking about they do that in a spin-off or in an independent company. We want to do that within SCHUNK, because that is we want to try it basically in a different way. But I'm saying that disruption is really a major step for a component provider building up a system where we're gonna sell services. And just a couple of examples. The focus right now is on 2D technology. We're able to pick always the same kind of objects. That's the very easy part. But we also, the system is open to all different kind of applications. It works. You're gonna see that on the lower right side. It works with Lego. Why is Lego important? Basically, you can build any kind of object that is not prior known to the system, and the system will still be able to grasp and to handle it. We also have an example of the on the lower left side where you're gonna see different kinds of objects. One of those objects is a very it's a soft tissue. Even that one can easily be handled because the system adapts to the shape of the objects once it is on the screen. That is the state of the art. What we do on, I have to hurry up. that is basically what we do on the grasping side. We do some 3D grasping also. That is still in the making, so it's not finished yet. But of course, the same kind of goal. So also here we look into how we can realize that. I just want to point out to one important. I'm gonna skip a couple of slides. Maybe that one slide, which is important for us. The idea of being able to handle information coming from sensors and make sure that they will be afterwards be used in application. It's basically what we're focusing at. Right now, the information is coming mainly from the gripper. Tomorrow, you can use a four-stalk sensor. Even that information can afterwards be integrated in the decision process. We also work on sensitive gripper fingers, so you can also have more information about what's going on there. And with that, you're going to see we go towards the applications. We're going to see here where we're going to do assembly processes. That's really, once the companies that are able to do that on a very flexible kind, that is, at least in my thinking, the major breakthrough in the future when we're able to do a manual assembly, automated assembly with the gripping tools we have around today. Just one more word. That doesn't stop really on the gripping side. We do exactly the same kind of idea. We're going to put sensors in any of our devices. The tool holder is one of the very easily understandable applications. The sensor goes in the tool holder, and with that we've got a perfect vision what's going on during a milling or a drilling process. And we use that information to help our customers providing better products. That was not on purpose. Okay. So just one video which explains basically what we are doing. Now video will not run, but basically what you're going to see here is that when you're in a drilling process, the sensor in the tool holder is able to figure out whether there's any instability or anything going on during that process. So when we see that there's a change in what we call the chatter index, when we're going to see some vibrations, that information either can be easily used for detecting when there has been a breakage of the tool, but also we're going to understand the quality of each of the drilling holes that has been made. And with that afterwards, in the long run, we can control and make sure that all the processes we're going to provide, we can control them and make sure that the quality of the applications at the end will be better than at the end. And you're going to see here the very simple example. Over time, you're going to see a change in behavior, and you're going to figure out that you're going to see that here now, there's some weird happening, and at some point, we're going to determine, from that point on, we assume that it's better to change your tool. It's a very different application from what I showed before, but it's the same idea. We've got a device which is able to collect information. We've got that box, that software, that is hosting the intelligence that SCHUNK will provide. And with that, we help to provide a solution to a customer in terms of improved milling, improved grasping, and automate the entire production process. And with that, I know it was fast. I'm very open for questions. But automation is basically what we did over the last couple of years. The next really key thing for us will be to make sure that we're going to talk about autonomy in the future, because we want to make sure that those devices, those complex production mechanisms, they work without manual interventions of humans. So the grasping has to work basically all the time. The milling process, without having somebody standing next to the machine and figuring out whether there has been some chattering or not, that needs to regulate itself and control itself from itself. And that, of course, that all combined in an autonomous network, that is what we think will happen in the upcoming years. And I hope I was not over time too much.